Hello. In this lecture presented by www.free-academy.com, we're going to be doing problem 3 out of the text, practicing our algebraic limits. So we've been given three functions here. The limit as x approaches a of f of x equals 2, the limit as x approaches a of g of x equals negative 4, and the limit as x approaches a of h of x equals 0. And with this information, we have to compute the following limits, or we have to determine if they don't exist, and just, so on. If they exist, figure them out. If they don't exist, explain why. So the first one, that's really easy. The limit as x approaches a of f of x plus 2 times g of x. Now we just need to use some of our formulas here that we learned. When we have the limit of two functions added together, this is the same as the limit as x approaches a of f of x plus the limit as x approaches a of 2g of x. But additionally, we also know that we can pull this 2 out in front because it's not dependent on the limit. Another way of looking at that, more complicated way, we'd have the limits as x approaches f of x, which I'm just going to, this. And this will be plus the limit as x approaches a of 2 times the limit as x approaches a of g of x. And this is all these formulas, these statements are perfectly equivalent here. Now, of course, the limit as x approaches a of 2 is equal to 2, which is why I just, wrote it out front there. So let me clear up this room here. There we are. Alright, so now let's actually compute the limit. We know that the limit as x approaches a of f of x is equal to 2 from our formula. So this will be plus 2 multiplied by the limit as x approaches a of g of x is equal to negative 4. So now we just multiply everything out. We'll get 2 plus negative 8. So this will be equal to negative 6. Let's go on and do the same thing for part B. We'll distribute out our limit, in which for convenience I'm just going to write the limits and ignore the x goes to a because they all go to a in this particular problem. So of the limits as x goes to a of h of x plus minus 3 times the limit as x approaches a of g of x plus, and this will be the limit as x approaches a of 1, which is simply equal to 1. Now we just go and take a look at the information given in our problem. Limit as x approaches a of h of x is equal to 0. This will be minus 3 times the limit of g of x, which is negative 4. And this will be plus 1. Negative 3 times negative 4 is 12, plus 1, 13. Oops. Now we can go on, and problem C here is the same thing that I did in problem A, where I did the limits of 2 and negative 4. We'll have the limits as x approaches a of f of x. This will be times the limit as x approaches a of g of x. That's going to be equal to 2 times negative 4, which is equal to negative 8. Now let me just delete all this here so I have lots and lots of room. And then we'll do problem F. F is the limit as x approaches a of 2 over g of x. This is going to be the same as the limit of 2 divided by the limit of g of x. And this, of course, using my notation for this lecture. This is going to be equal to 2, and then the limits of g of x is equal to negative 4. So 2 divided by negative 4, or negative 1/2. Now we can go on and we can do problem G. The limit as x approaches a of 3 times f of x plus 8 times g of x divided by h of x. Well, we'll distribute out the limits to everything here. The limit of f of x is equal to 2, so that's 3 times 2 plus 8 times the limit of g of x, which is negative 4, times negative 4. This is divided by the limit of h of x, that's equal to 0. Well, if you have a 0 in the denominator, this limit does not exist, it's undefined. So you can never divide by 0. Now let's go on and we'll do the final problem, which is h. And we have the limit as x approaches a of 7 times g of x divided by 2 times f of x plus g of x. Now in your head you can distribute out the negative, or you can distribute out the limit as x approaches a, and you'll get 7 times the limit of g of x, which is equal to negative 4. 7 times negative 4 divided by 2 times the limit as x goes to a of f of x, which is equal to 2, plus the limit of g of x, which is equal to negative 4. And once again on the denominator we're going to have positive 4. This is going to be minus 4. We'll have 0 on the denominator. So this is once again undefined. So that's our lecture on, that's another practice on solving limits algebraically. And we'll have some more, and feel free to send us any questions if you have any.